Hello, this is Pilar and today I will be talking about the transfer of olfactory memories established during pollen collection to the classical context of the proboscis extension response. The ability to transfer learned information from one context to another is a trait that allows animals to make more efficient use of their memories. Nevertheless, distinguishing learned information in equivalent context could also be functional in certain circumstances. Pollen and nectar have been extensively considered equivalent rewards for the honeybee Apis mellifera. If this is the case, information learned with one resource could also affect behaviors related to the other. However, differences in the nature, usage, and even the way these resources are collected led us to believe that associations established with each of them might be different. The foraging behavior of the honeybee is partially based on classical conditioning, where animals learn to associate a conditioned stimulus, for example an odor, with an unconditioned stimulus, for example food. In bees, studies on classical conditioning have focused on the olfactory conditioning of the proboscis extension reflex, a response closely related to foraging of liquid food. In this context, we hypothesized that the memories established with pollen or sugar involve distinct and resource-specific associations and do not transfer to the same extent to the classical context of pair conditioning. For this, we trained bees to visit a scented pollen source and evaluated the extent to which these memories influenced the performance of experienced foragers in the proboscis extension reflex conditioning. We included 3 additional groups of foragers, those trained to a scented or unscented sugar source and to an unscented pollen source. We conditioned the bees using the experienced odor as a conditioned stimulus and a sugar solution as the unconditioned stimulus, during 5 events spaced 10 minutes apart. This was followed by 4 extinction events where the odor was presented in the absence of the sugar solution. We registered the proboscis extension triggered by the mere presence of the conditioned stimulus as the response. To corroborate that experiences established at scented food sources led to the formation of memories, a second group of trained bees was tested in a 4-quadrant olfactometer. 2 of the quadrants were odorless, while the other 2 presented the scent of the experienced odor or a novel odor. We evaluated the proportion of time the bees spent in the quadrant with experienced odor. As we expected, experienced pollen and nectar foragers were able to use information learned at the sources to orient themselves in the olfactometer. The analysis of the proportion of time the bees spend in the quadrant with the experienced scent showed that the type of foragers interacts with experience. Experienced foragers, both pollen and nectar, spend a significantly greater time proportion in the arm with the experienced scent. We also observed that among the experienced foragers, nectar foragers spend an even higher proportion of time than pollen foragers. Here, we observed that memories established at scented pollen source inhibited pair conditioning, as the levels of conditioned response are lower than those of the control groups, both foragers trained to unscented sources and nectar foragers trained to scented sources. The analysis of memory acquisition showed a significant effect of the trial and a significant interaction between experience and forager type. While pollen foragers with experience at the source exhibited lower proportions of pair, this was not observed in nectar foragers. In contrast, there was no significant interaction between experience and forager type in the analysis of memory extinction. In this work, we showed that memories established at a pollen source can inhibit pair conditioning, suggesting that memories formed in the context of foraging are resource-specific. In this sense, we found that memories formed at pollen sources inhibit the acquisition of the same piece of information associated with sugar. This could be explained by the fact that pollen foragers do not ingest the resource during foraging, raising the possibility that this resource is processed through different neural pathways from those that mediate sugar-related associations. If this were the case, visits to a scented pollen source would act as olfactory pre-exposure for these latter pathways, leading to latent inhibition of the sugar reward pathway. This form of learning could contribute to specialization among foragers. Thank you for your time.